7.NS.1.b. This is the 7th grade number system standard 1 with the subpart of B. We are going to continue our talks about integers, and we're going to add integers today using a couple of different rules. I know that we're going to be using the number line to show how to put negative and positive integers together, and I'm also going to teach you a new technique that you might not have learned before. Terms to know, please pause the video and write down the definitions to these words. Right from the standard, it says in the wording, remember that paragraph was very, very long. I'm going to try to break down the standard for you and use some wording or some techniques that might make more sense to you. The standard says, represent addition and subtraction on a horizontal or vertical line diagram. Now today we're not going to be dealing with the subtraction per se. That has their own set of rules in itself. Today we're just going to be dealing mainly with the addition of these numbers, these integers. So it says 3 plus 4. You all know what the answer to 3 plus 4 is, but to show it on a number line diagram, I'm going to take my marker and I'm going to start at 0. I'm going to go from 0 to 3 because I am starting at 3. If I'm going to add 4 to that, what direction do you think you're going to go if you're adding 4? You're going to go to the right. So I'm going to draw maybe a little dotted line up above and then go to the right 4 units. So let's go from 3 over 4 units. Count them out, 1, 2, 3, 4, and maybe draw my little dotted line up, connect them, and we have just added 3 and 4. Let me shade that line maybe in a different color. I think the book uses 2 different colors to show what they're doing here. So maybe we'll change this to purple line. Okay, so that is 3 added to 4, and as you can see, we went 3 units from 0 to the right. Just kind of branched it up to show the second part of the problem. We're adding 4, and we land at 7. So 3 plus 4, as you all know, is equal to 7. Now we have a negative integer in play here, and it says negative 1 added to 5. So on the number line, we go from 0, always start from the origin 0, and go to the beginning part. We started at negative 1. And we're going to draw our little dotted line. And we're going to go 5 units. Now what direction do we go? It says add positive 5. So adding 5 always means go to the right 5 units. So let's count it out from this spot. 1, 2, 3, 4, 5. And let's use that different color, maybe go blue. And we went to the left. So we ended up, maybe we could put an arrow on the end of these two. So we went from negative 1 to the right 5 units, and we ended up at positive 4 as being the answer to this. Later on, I'm going to teach you another technique. For right now, let's just concentrate on the number line, 4. 3 added to negative 6. Stay consistent here. Start at 0. It says to go to positive 3 first. 1, 2, 3. Maybe a little arrow there. And we are going to add negative 6. Now, these back-to-back signs, adding a negative, really means subtracting. So it doesn't say add 6, go to the right. It says add -6, which you would have to slam on the brakes and go the opposite way instead. So adding a negative means subtracting, so we're going to go back 6 spaces. Let's count it from here. 1, 2, 3, 4, 5, 6. And let's see where we are here. We are at -3. We landed at -3. So let's put that down here. -3. We go from -4 this time. So we're going to start down here at -4. So 0 to -4. You don't have to put the arrows. I'm not going to on this one. And then they want you to add -5. Recall that when you're adding a negative, you're actually going in reverse. Adding 5 would be go to the right. So if we add -5, we're going to go to the left 5 units. 1, 2, 3, 4, 5. And where did we end up? We kept going over here, and we ended up at -9. Well, if I'm going to teach you a different technique, that technique works really well with numbers that will get you in the answer range of like -10 to +10. Sometimes the numbers are going to be, or the integers are going to be much larger or very much smaller in terms of negative numbers. So it's very important to know what the absolute value is, because if I teach you the absolute value, you're going to need that for the next method. So the absolute value has a symbol here. And if we just look at this, it says, what is the absolute value of 5? Well, the basic definition, if I were to tell you, is the number of units away from 0 that number is. So if I'm looking at the number line and here's my 0 and it says how many units away is this 5, we just count them out. 1, 2, 3, 4, 5. And I usually, if you were with me in the class here, I would teach these little bunny hops. So the absolute value of 5 would be 1, 2, 3, 4, 5. So the absolute value of 5 is 5. It's just the distance away from 0 on a number line. Now, if we're going to compare that to the absolute value of -5, the absolute value of -5 is the same idea, except we are going the opposite direction, but we're still counting the same amount of jumps. So where is -5? It is 1, 2, 3, 4, 5 bunny hops away. So the answer to this is still 5. Don't get into the negative values. They're not talking about negatives. In the definition, it just says the distance between that number and 0. So how many bunny hops you are away, whether it be positive or negative, it doesn't matter. The positive 5 was 5 jumps away, and the -5 was also 5 jumps away. And again, if you were in here, you probably would see me doing the bunny hops for you. I'm actually bunny hopping around the classroom right now. I wish you did. It's really a good show. Where is that going to come in handy? That's going to come in handy, that absolute value, when we come into adding these larger numbers. So I have a definition sheet or a rule sheet here. It kind of gets confusing, but I am going to take each one of these rules and kind of break it down for you using examples. So you might want to write this down so that after I explain these problems, you can go back and it might make a little bit more sense. Okay, according to rule, it says, I know it says to pause the video and practice. You can pause the video and practice if you understand the rules, but as of right now, I'm going to go through these 4 problems. It says 10 plus 14. Well, we all know the answer to 10 plus 14. This is 24. 4. Now, if I were to follow the rules, I see that the positive 10 is added to the positive 14. So if I went back to my rules, I would use the positive plus positive and kind of follow what this green stuff means. And I'll tell you what the green wording is explaining. It says, take the absolute value of both of your numbers, absolute value of 10 and absolute value of 14, and add those numbers, 10 and 14, to get 24. You're to add them just as it states in the problem. And then you're going to take the absolute value of them, which we know that this is 10 bunny hops away and this is 14 bunny hops away. And what absolute value is bigger? Well, 14 is greater than 10. So whatever the sign is in the original problem next to the 14, it is positive. I'm going to take that positive number into my answer, and that is 24. So we had a little use of the absolute value sign here. Now, the next problem down says -7 plus -5. So I'm going to take that same idea and follow the rules from the previous page, and it looks like it is the -7 plus -5, which is a negative plus a negative, and we're going to follow this green rule again. So read the green rule. We're going to add these numbers up and then follow the absolute value game. Let's see if I can't move this out of the way. Well, that didn't work. How about this? Let's just throw it out for now. Okay, so we have -7 and -5. Let's take the absolute value of each of those. Absolute value of -7 added to the absolute value of -5. All right, what are the absolute values? Well, this one is 7, and this one is 5 bunny hops away. So who's bigger? Well, 7 is bigger than 5, so we're going to steal the answer, or the sign from that, into our answer. Add up our numbers. 7 and 5 gives us 12. Steal the sign of the largest absolute value, and that must be negative. So the answer is -12. Don't worry, it's not going to be that. We're going to work a lot on these problems, and the more practice you have, it's going to come to you real quick. I know it sounds a little confusing, and I'm probably talking a little fast. I apologize for that. Let's get rid of this one now. Problem number 3. -11 added to 6. So we have a -11 absolute value added to a +6. Now, this looks a little different because I have a negative added to a positive. So let's go back to our rules and find that. So a negative added to a positive, we are actually going to then subtract these numbers from each other. So 11 and 6 gets me some kind of 5, right? We're going to subtract those now, but we're still going to play the absolute value game. What's the absolute value of -11? Well, that is 11 bunny hops away from 0. This 6 is 6 bunny hops away from 0. What's bigger, 11 or 6? The 11 is greater than 6, so we're going to take the sign of the higher absolute value, which was negative. Last one. 13 added to -9. Well, this is a positive added to a negative. Let's go back. A positive added to a negative. We're going to follow this general rule here, and again, we're going to have to subtract those numbers. So 13, absolute value of 13 added to the absolute value of -9. Remember, we're subtracting because the signs are different. So if the signs are different, we're different than adding, we're going to subtract them. And we're going to have some kind of 4. Well, we can't decide what kind of 4 until we take the absolute values. This one is 13 bunny hops, 9 bunny hops away. 13 is greater than 9. We steal the sign from 13, which is positive 4. Positive 13, so positive 4. Last problem, we're going to take this and describe a real-world situation. Again, taken right from the standard. Charlie owes his friend $10. Oh. After 1 week, he pays him $6 back, and after the second week, he pays him $3 back. Write and solve an equation to show how much Charlie owes him after the second week. In word problems, I like to read them multiple times. I'll let you do that on your own. And basically it says we have to write an equation and then solve it. So what do we start with? Charlie. Charlie owes his friend $10. So here's the beginning of our equation. We have $10, and what do we have to do with that $10? Well, after the first week, he's going to give him $6, and then after the second week, he's going to give him $3, and then we have to figure out after the second week, what is he still going to owe his friend? Well, we don't know. We need to figure out what is going to get us up to 10, so that will be a variable that's missing. So if we were to solve this, 10 is equal to 6 plus 3, which is 9. I don't know what I owe him. Well, I really do know because it's kind of an easy problem, but what does Charlie owe his friend in the coming weeks? Well, if he borrowed or owes him $10 and he only gave him back 9, what do we have left? Well, X is going to have to equal $1. So Charlie owes his friend $1. We will be doing many, many more of those problems this week in small groups, or if you're having trouble, we can work on this individually in your journal. Define the given terms from page 2 of the flip chart. Write a few sentences on what you learned from this video, and please describe one real-world situation in which you can interpret sums of rational numbers. Kind of like what I did there with the Charlie example. Can you come up with one of those Charlie examples? See you in class.